Hi students, this is Mr. Yang. In this lesson, we will learn the second thing about vectors and matrices together, which is about how to find the area. Before we do that, let's review something we have learned before. So question A. That is the notation. The single bar in matrix represents finding the determinant. So we are going to cross them. We are going to connect the diagonals, use one diagonal, subtracting the other diagonal. 1 times -2, subtracting 3 times -4. That is -2 plus 12, which is a 10. Then question B, this time you are given the DET, which means for finding the determinant. Again, these are just two different notations about determinant. 2 times 1 minus -1 times 0, so a 2. C, given that A is -1, 4, and B is 3, -2, it is asking you to actually graph the vector. So A is -1, 4, and B is 3, -2. We're going to need to label A and B, then draw a vector from A to B with an arrow, and that is vector AB. That's question C. Question D. A is -3, -2. B is -6, +3. That's our A, that's our B, and it is going to be from A to B, and an arrow, that is our vector AB. That's question D. Moving on, in this lesson, we will learn how to find the area of triangles and parallelograms using component vectors and determinant of matrices. First, area of the parallelogram. Given vector AB, B, which is AB, given vector U, which is CD, we can find the area of the parallelogram formed by the vectors. Because we have learned how to draw the addition with parallelogram rule, so that's why we can actually do that. We'll generate a matrix by stacking the vector V on top of the vector U. So AB, you can see, is the first row. CD is going to be the second row. The area will be the absolute value of the determinant because area is always going to be positive. So now let's have a look at an example with steps. Step 1, write two adjacent sides as component vectors. Adjacent means they are next to each other. So for example, we can choose to do AK. To write the vector, we are going to need to go from A to get to B. Or you can use the coordinates K subtracting A. But in this case, horizontal first, 1, 2, 3, going to the right, 4, and then going down 1. So 4, -1 is AK. But we are going to need to write two adjacent component vectors that start from the same point. So AK, and the other one would have to be AM. And AM is going to be to the left 2, so -2, and then up 3. So -2, 3. Step 2 is we're going to generate a matrix with the two vectors. So we're going to stack them together. 4, -1 is going to be the first row. -2, 3 is going to be in the second row. Step 3, we are going to find the determinant of this matrix. So the determinant, we can put them in. 4, -1, -2, 3. So the inside bars represents the determinant. The outside bar represents the absolute value. So it's going to be the absolute value, diagonal subtracting the other diagonal, 4 times 3 minus -1 times -2. So we will have 12 minus -1 times -2 is a 2. So 12 minus 2, which is a 10. So the area is going to be 10. That is the example with steps. Now let's do a few practice. Find the area. Since I already did AK and AM, this time I'm going to choose a different one. For example, I can choose MA this time. MA from M to A is left 3, then down 4. And then I can choose MR. From M to R is 1, 2, 3, 4, 5. To the right 5 and up 1. It is a bit similar comparing to finding the slope. However, finding the slope, you have to do rise over run. So you got to go vertical first and then horizontal. In this case, since we are writing coordinates, that's why we have to deal with X, which is horizontal first. Now, I'm trying to find, I don't even need to write the matrix because the determinant is going to show me the matrix. -3, 4, -5, 1. The inside is going to be the determinant, -3 times 1 minus -5 times 4. and the outside, well, already have the outside with the outside value, so -3, then it's going to be plus 20, which is a 17 inside, which means the area is just 17. Next, example 2. Since I already used the letter M, let's choose another one. Let's say I'm doing RM and RA. Again, emphasizing when you're trying to write the two vectors, they have to start from the same point, because that's how we write the adjacent vectors. RM is left 2 up 2, so -2, 2. RA is left 2, down 3. So finding the determinant of -2, 2, -2, -3. That is going to be -2 times -3 minus -2 times 2, which is going to be a +6 minus a -4. So +6 plus 4, which is a 10. That's example 2. Moving on, example 3. This time you are given the points. You can choose to draw the points and then find the vectors, or you can just use the points to find the vectors. Let's say you're trying to go for AB, but you do need to know AB and AD are going to be adjacent, but by knowing they are starting from the same point. So AB, but this time if you are using the points to find the actual component vector, you are going to need to use B subtracting A and D subtracting A. So it's going to be 3 minus -1, then 4 minus 2, which is going to be 4, 2. AD is 3 minus -1, -1 minus 2. That is going to give you a 4, -3. So to find the area, stack them up. 4, 2, 4, -3. That is going to be, I can also write letter A in the front to indicating I'm finding the area. 4 times -3, subtracting 4 times 2. So -12 minus 8, which is -20 inside absolute value. So the area is going to be 20. That's example 3. Example 4, there may be a typo, so that should be point C as 3, -1, and D as 0, -2. I think the points were switched on your notes. So this time, let's choose a different point. Let's say we're starting with B. Then you're going to need to find BC and BA. Again, starting from the same point, indicating they are adjacent sides, adjacent vectors. So BC, we're going to use C minus B. And the other is going to be A minus B. So C minus B, that is going to be 3 minus 2. Then A minus 4, we're going to get 1, -5. BA, we're going to use -1 minus 2, and then 3 minus 4. That is going to give you -3, -1. So stack them out to find the determinant. 1, -5, -3, -1. That's going to be 1 times -1, subtracting -3 times -5. So we actually have -1 subtracting a +15, which is a -16, which means the area is just going to be 16. That is example 4. Moving on, area of triangle. If you think about it, triangles are just half of a parallelogram. Let's say this is your parallelogram. Well, I can cut it, then I have 2 triangles. So that's kind of the only difference. It's exactly the same process until the very end. We are going to multiply the result by 1/2. Emphasizing on we're going to multiply the result. We're not just going to multiply the 1/2 into the whole thing. That's going to change the result. That's going to change everything. So now let's look at number 5. You can choose to pause here and try it out. And I suggest you to choose some different vectors compared to the ones I'm going to use to confirm. Even if you use other vectors, as long as they are adjacent, you will still be able to identify the area correctly. So for this one, I'm just going to go with HG. From H to G is down 5 over 1, so it's over 1 down 5, so 1, -5. And then the other vector would have to be I meant HU. The other one now is HG. That is 1, 2, 3, 4, 5. To the right, 6, and then down 2, so 6, -2. Finding the determinant, 1, -5, 6, -2. It's going to be 1 times -2, subtracting 6 times -5. So we'll have -2 minus a -30. So basically -2 plus 30, which is going to be a 28 as the area. But we are still going to need to multiply the result by 1/2. Because the 28 basically represent the parallelogram formed by these two sides. I still need half of it to represent the triangle. That gives me the triangle area as 14. Next, example 6. Let's say we're going to do CB. CB, I'm going to need to use B minus C, so 4 minus -1, and then -2 minus -3. That is going to give you CB as 4 plus 1, which is 5, -2 plus 3, which is 1. And then we have CA. Again, starting from the same point, indicating they are adjacent vectors. CA using A minus C, 1 minus -1, 2 minus -3. That's going to give you 2, 5. Now time to find the area. First, the average value of the determinant, 5, 1, 2, 5. So we are going to have 5 times 5 minus 2 times 1. So 25 minus 2, which is 23. Eventually, I still need to multiply it by 1/2. It's going to give you 23 over 2, or 11.5. That's example 6. And that is everything for this finding area lesson. Thank you.